Welcome everyone. This is all about Docker containerization. So this is maybe kind of like a buzzword type of term now. So what this workshop is going to be about is kind of peeling back the layers, seeing how containers work at a very not superficial, but a very high level. So if you don't know like a lot about Linux or a lot about like programming in general, that's okay. But what you'll get out of this is kind of the building blocks of like what is a container, like in a very high level, and you can use that later when you're like making decisions about containers, that kind of stuff. But let's get started. So the agenda for today, it's basically going to be in 3 parts. So the first part, we're just going to be talking about what container-based virtualization is. So you're going to talk a bit about what virtualization is. I know like when you look online about Docker or like virtual machines, you'll just hear the word virtualization a bunch, and it's kind of like meaningless, right? Because you hear it so many times, but you won't hear it like defined. So we'll talk a bit about that. We'll talk about why people use containers, like what's the point? Why do we have this another thing to learn on top of everything else? Then we'll talk a little bit more about how containers work. You notice I'm not like using specifically Docker. So Docker is a kind of container, but we'll kind of look at like the general practice, like the general technology behind it all. So we'll look at some of the components, and then we'll also see how these components work in practice. Afterwards, we'll take a short break, and then we'll get on to the hands-on part. So for the hands-on part, try to have Docker installed. If you don't have it installed currently, that's okay. You'll have time over the break. Do keep in mind that when you install Docker, particularly on Windows, I'm not sure about other platforms, but Docker on Windows will need you to restart. So that might mean that you leave and then rejoin. And so that's what the break is for. So let's get started. So part 1, what is container-based virtualization? So container-based virtualization, basically what we're doing is we're providing an operating system scale virtualization system. And I know that is like using kind of, I'm defining what container virtualization is, but I'm using the word virtualization in that definition. So it's not very helpful. So let's maybe take a step backwards. What do we mean by virtualization? Well, when we virtualization is like a very big computer science concept, and it basically means to model something. So we have our like real device, and then we might want to have a virtual device, which maybe the computer treats it as the same thing as like a real device, but it's kind of imaginary, so to speak. So a great example, and actually an example that directly applies to containers, is virtual network adapters. A physical network adapter is something that like I would buy, and I would switch off my computer, and I would have to plug it into the PCIe port, and hopefully everything works out. Usually today everything works. It's something real, right? And then I have to physically plug in a cable. A virtual network adapter uh, does not have that physical port, right? It's something that kind of exists, like my computer thinks it exists, but it's not something I can like tangibly hold or touch. And you might be wondering like, why? Like this is just confusing. Like why would you care about having a virtual network adapter? And there are many benefits. One, we can mimic something that is real. So like we can basically kind of like make a copy of something. And so this is often useful, right? When we talk about like operating systems virtualization, we might want to make a copy of our operating system, and maybe that copy is great for certain reasons, right? For example, we could destroy the copy, and our physical real computer isn't touched. So to show a great example, I'm just going to show my screen right now, and I'll open up the terminal. Okay, I'll move this to another screen so it doesn't look weird. So I just have a terminal up, and what I'm going to do is type in IPA. You don't need to know what that means exactly. Um, but what it does is it just lists my network adapters. And so it's kind of super verbose, like it's a very like complicated output, but I want you to focus on these numbers. Each number like signifies a different network adapter. And you notice I'll have one called ENP5S0, ENP6S0. These are real network adapters. But then you'll notice I have one called Tailscale0. And what Tailscale is it's just like I'll open up the website for Tailscale. It's just a very fancy VPN, right? If you're familiar with what VPNs are, you can see where I'm going. But basically, what this Tailscale0 is it's a network adapter, but it's not real. It's virtual. So I can send data to this network adapter, and the network adapter will accept it and transmit it to my virtual network, but it's not something that is real. And how Tailscale works is you just install it on whatever device you want to be part of the same virtual network. So basically, I have Tailscale on here. I can install Tailscale on my cell phone and then both log in. And then my cell phone and my computer can talk to each other as if they're on the same like network, as if there's like a physical network cable plugging my phone into the PC, right? So that's like why we really like virtualization, right? Because imagine there was a magical device that you could buy and you can plug into your computer, and then you can talk it to any other device with the same thing that you bought. Great, but you still have to buy something, right? This virtual adapter is just something I install. um, it works well in Linux because Linux knows how to deal with like Ethernet adapters. So it kind of fits in. It's not real, but who cares, right? It still provides a lot of benefits. um, Moving on, virtualization can make something easier to use. Um, so on the image on the right, I have a screenshot of VirtualBox. If you don't know what VirtualBox is, it's a really cool thing you can use to run virtual machines. And it's a little bit easier to use VirtualBox to like launch like a Windows virtual machine than it is to like sit down, plug in a USB to your computer and install Windows manually, right? So sometimes the ease of use can make things better. Um, Another thing is to add improvements, right? So going back to the virtual network example, um, it's a virtual network adapter. It doesn't get a real network port or anything like that. But it lets me communicate all across the internet over like a very secure like virtual network, right? So it adds a lot of improvement that you couldn't possibly see with a physical network card. So that's what virtualization is in a nutshell. It's just modeling something, and it's just like, pretending that we have a copy of a real thing, and um, we do so because sometimes it's nice just to have a copy, right? We can really mess up the copy and nobody cares, right? Because it's just a fake copy or a virtual copy. It can make things easier to use, and sometimes it can add features that we like. It's hard to see with like a physical device. So that's what virtualization is. Let's kind of narrow in more about operating systems. I used to have like a couple of slides on this, and I took them out because it was kind of too much historical context. But the sum of it is we often want to virtualize operating systems. Um, we do so because it's a lot easier to manage like a purpose-built OS than it is to like, install Windows and then install like every possible service, all at once. If you think about like a company, they might have like several websites that they're hosting. They might have like a SQL database server, and they might have like X, Y, and Z. So many programs just running on one machine. And sometimes when we install lots of programs, they conflict with each other. One program could like dominate and like take a lot more resources, right? Imagine like you're hosting a SQL server and it gets hacked, and it's like a denial of service attack. So it's basically your SQL server is like run by hackers, and it's just like generating a lot of noise, and then the rest of your programs like can't run very well because the SQL server is just going nuts, right? So that's why we want to virtualize operating systems. Another way you might think about this is, if you've into gaming, maybe you've thought about like building like the fastest possible like Windows gaming machine, right? And so that virtual machine, that operating system that you install, like Windows, maybe you'll like tweak it down and try to make it as fast as possible, right? Virtual machines kind of operate in the same principle. You want to like have an operating system that is streamlined to um, do what you want. There are two ways to virtualize operating systems today. You have virtual machines. They're like the old legacy standard, and then we have containers, and that's what we're going to be talking about today. I'm just uh, checking the chat. Yes. So Tulio said that it's easy to share. That's another really great thing. If you're into IT, you might have heard of a concept called a golden image. What a golden image is like, maybe I install Windows Server on a machine, and it's a virtual machine, by the way. So it's a Windows virtual machine that it runs Windows Server, and I configure it to however I want it. And then I can save it, and maybe I can send it out to like my colleagues. I can back it up, right? There's so many great reasons for virtual machines. So I talked a bit about this already. So why do we care about operating system virtualization? Well, general management tends to be a little better, right? We can manage dependencies, and we can make deployment a little bit easier. I have a bit of a duplicate there. But a virtual machine is, or a virtualized operating system is stored as a file on disk, right? It's a lot easier to just send that, right? You can make copies of it and so forth. OS virtualization also helps with security. So I talked a little bit about like the problems that you might have when you have like a ton of different programs running on the same system. Part of that is kind of due to that hacker situation I was talking about. The worst case scenario is applications reading each other's data, right? Imagine I am running my SQL server and I'm running a website, right? And this time the website gets compromised, right? The website code controlled by the hacker might try to like sneak in and see like, hey, let's read the database. Let's see like the sensitive information that this computer is holding, right? Not a very good idea. And if you can isolate it so that we have different operating systems that are virtualized, they are isolated. So just because my SQL server virtualization gets hacked or my web server virtualization gets hacked, they can't talk to each other, ideally. Of course, exceptions always exist, but OS virtualization always provides a layer of security. And lastly, it's reproducibility. So this kind of helps with general management, right? So backups, you can take backups of OS virtualization. See, it's really helpful for like disaster recovery. A few weeks ago, I ran a dev container workshop, and in there, we talked about developer and build environments. So a dev container is running on Docker, and it's really great because you can just recreate it easily. If you've ever dealt with like Visual Studio and like trying to work with a project, then you might run into issues where it's like, oh, you have to install this NuGet package and configure these project settings, so forth. Very hard, right? And imagine you had like a team of 100 people or even 10 people, right? It could pose a lot of problems. So I talked about virtual machines and containers. Why do we have both, right? Why don't we just use virtual machines? The short answer is that containers are newer and they are a little better generally. So one comparison we can make, and this is kind of like the key comparison. If someone was to ask you, what's the difference between a virtual machine and a container? The answer is that the virtual machine virtualizes hardware, and it always does. So my virtual machine in VirtualBox, if I opened it up, it's emulating or it's virtualizing a 64-bit computer, right? And it does so for each one. So I have Windows here and I have a Linux here. These operating systems are expecting an x86 architecture, and it works with it. So it's a lower level virtualization because it's closer to like the bare metal, so to speak. Containers instead virtualizes operating systems. So it's very often Linux-based. So you can think of it as kind of like a higher level virtualization. Containers don't care too much about the underlying architecture. It just piggybacks off of the host. So I'm running a 64-bit computer. And so my containers will always be 64-bit, right? If I was presenting this from a Raspberry Pi, I could still run containers, but those containers will be ARM-based, right? Because the Raspberry Pi runs an ARM processor. Let's talk about performance. As you might expect, virtual machines tend to do a little worse because it's it's virtualizing like hardware, right? It's like if you've like ran emulators for like Game Boy or GameCube or whatever, you might notice that the performance is sometimes a little slow, even though a GameCube is like a very slow device, right? It's from 2001. So why does my 2022 computer struggle with it? And the reason is because it's pretending that it's a GameCube, and that takes a lot of work. With virtual machines like x86, 64, you don't find this problem as much, but it's still a concern. Containers, on the other hand, tend to perform better, just because it does less steps, so to say. Security. Let's talk about security. So the virtual machine, each virtual machine will have their own kernel. I bold kernel, and I won't explain it now because I will explain it a bit later. So basically, when you're talking about security, the more sharing you have, the worse, right? Because when you share a resource, say you have so the kernel is kind of like a connection between the hardware and the software. So if you were to share the kernel, it's kind of like another place to attack. And that's usually the case with anything in security. The more things you share, the more you open up yourself to attack. So containers typically share a kernel, not always. And because of this, we would deem it worse, but in practice, it's really hard to say. And then so for deployments and redeployments, virtual machines historically has relied on manual processes, though today automation does exist. Whereas containers, because containers are newer and because they've kind of sort of replaced virtual machines, it gets a lot more focus in terms of automation development. So if you know containers very well, then you often have an easier time with deployment and redeployment because more people have spent time trying to automate it. Cool. I'm just going to check the chat. Yeah, so dependencies. Yeah, so dependencies is a really huge issue. And the solution, I did have a slide on this before, but the solution to dependency management today is just to bundle everything together. I'll open VS Code up and show this around. VS Code is basically just a browser, right? And it packages its own Chrome-based browser, right? Because when you install VS Code, it doesn't want to check whether you have Chrome installed, right? And maybe this version mismatch and so forth. Huge amounts of problems. So what you see with like modern apps like VS Code, they just bundle everything they need because computers can do that, right? And we're in the age where that's just a possibility. So let's move on to part 2. So how do containers work? I'm just going to take a quick detour and talk about Linux container internals. So one thing I'll say is that Windows-based containers technically exist, but you can ignore them for now, maybe forever. Actually, when you install Docker onto Windows, it'll default for Linux containers just because that's the dominant thing today. And how Linux provides containers, I'm not sure about Windows, but in terms of Linux, the main gist of it is that one, Linux has a lot of tools to virtualize components. So you can create a virtual Ethernet pair. And what will appear is two Ethernet adapters on your machine, and they're connected to each other. So when you send data on one cable, it shows up on the other. Yeah, so it's a very basic building block. And this applies to bridges, right? If you know what a network bridge is. And it even provides some network access translation, which is just like a tool we like to use when we talk about virtual networks. The other thing that Linux provides on top of these virtual Components is a thing called namespaces, and namespaces is a really old technology, but it's been a game changer once people finally realized what the potential was. What a namespace is it's like a different view of your Linux OS environment. And this limits determines what a program can see. Uh, so, for example, there are types of namespaces called mount namespaces, and these have to do with files. So, two different like file namespaces. Um, if a program belonged to one file namespace, it can only see the files that that namespace, decides upon. And similarly, if you belong to another namespace, you could see a different set of files, right? And right now, like when I just use, like I'm using Ubuntu, like desktop, right? So this is just a default namespace. But if I was to create a container, it will actually end up creating different namespaces. So we can see how these pieces are can be put together, right? I might create a network type namespace and then stick a virtual Ethernet connector in that namespace, and then put the container code in that namespace, or like make the container code run in that namespace, specifically saying. And then when that code starts, it can only see that one Ethernet pair that's virtual, right? So we can kind of see containers aren't like a single technology. It's actually a bunch of technologies that work together. And the last bit is a thing called C groups, which is similar to what namespaces, except it limits how much a program can use. So like talking about like CPU or memory, C groups is just like a thing to like make sure a particular program doesn't use all of the resources and not leave any to share. So this is kind of like a high level diagram of what is going on with containers. So we talked about this OS kernel a bit, and the OS kernel is kind of like the core or heart of your operating system. Windows has a kernel, Linux has a kernel. Linux is the thing that Linus Torvalds works on. He doesn't really work on anything else. Well, he does, but he primarily focuses on the kernel. And the kernel like provides like functions like fopen and that kind of stuff in C. It interfaces with your PCI hardware, right? So like if you have a graphics card, the kernel is responsible to like figure out how to work with it. So you can see it's like a lot of like low level technical stuff that we really don't care often about, right? Like I don't care about a GPU usually. I just want to run a website, right? So what we do is we split this kernel up and we say, okay, kernel, you will be responsible for a bunch of different collections or namespace collections. So we have our default one. This is maybe the one that you can see I have Chrome open. Chrome is running in the default namespace for me because I'm in Ubuntu Linux. The container runtime, so like the Docker program. So when I type in Docker, that's running in the default namespace, but it's able to like figure out what's in other namespaces. We'll have this thing called a local image registry, which is what we'll talk about later. This is basically just like a storage spot for images, which we'll talk about later. And then I have like a random user program, right? So I said Chrome, right? Chrome would be running in the default namespace. If I had an SSH server, that would probably be running in the default namespace, and so forth. And then we can see we have different namespace. And I say the namespace collections because, as I said before, there are different types of namespaces. So there's a network namespace, and that changes like what networks a program can see. There's mount namespaces, which change what files you can see, so forth. So we usually create several namespaces and call them a collection because they all relate to one container. So one container will get a network namespace, we'll get a mount namespace, and so forth. And in this namespace collection, I'll have what we call an entry point script, right? So we'll configure all of these namespaces, blah, blah, blah. That's basically providing a specific view for the container. And then in that view, we launch a script. And that script just kickstarts whatever we want the container to run, right? So maybe I have a SQL Server container, right? It'll have an entry point script. I'll run it. That entry point script will start my SQL Server and so forth. And basically everything that entry point script does has to work within this namespace collection, right? So for example, this entry point script won't even know that I'm running SSH, right? It won't even know anything about the default namespace. It's when this entry point script starts up, it looks around and it says, oh, I'm in an operating system, right? And there's nothing else here except me, basically. So that's kind of how these work together. Just checking chat. So I talked a bit about some of the components. So let's just dive in a bit into a bit more detail. There are three major components. There are obviously more, but these are the ones that you should focus on when you're first learning about containers. One is an image. An image you can think of as like an installation disk, right? So I have played lots of video games when I was a child, and they came in CDs, right? And I would put the CD in, and I would look around on the CD, like see what there is, and what the CD will have is a copy of the game, right? And then when I run setup.exe, it'll copy those files onto my hard disk, and then still requires the CD to be present to play, but like most of the data from the CD is onto my computer, right? So we take the installation disk and we copy it onto my computer, and then my computer is able to run the game. So really think about it as like an installation disk. The image will have all OS files. If you're familiar with Linux, you might think about like the root file system, so forth. But if you don't know about that, that's fine. Just think about the image as containing all of the OS files, right? If you're familiar with Windows, it's like your C drive. The image is stored on a registry. It can be stored on many registries, actually. But things like dockerhub.com, that's a registry, right? And so that's how we get our images from. And as you might expect with an image, you can create and you can delete them. You can't run them because the image is the installation disk, right? To run something on an image, you need a container, right? The container is a running instance and it's derived from the image. So I might pull down my SQL Server image and I want to start a container. Well, the container is going to be derived from that SQL Server image. But as soon as that container starts, it's going to start to look different than what the image is, right? So in the case of SQL, I run the container and add a database to it and blah, 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 do some operations. Well, now that container stores all the files that the image had, plus any like database files that I created when I was running the container. And so the container operations include create and delete, but they also include start and stop and some network operations that we can talk about later. But yeah, the container is the thing that you're starting and stopping, but it is built off of the image. And lastly is the registry. That's just the server storing images. How Docker works, and this is actually kind of a common design pattern that you might encounter, is that Docker will have a server storing images, but then your computer will like secretly have its own registry too, because that's how we kind of cache downloaded images. So when Docker runs, it first checks the local registry and says, hey, is there an image for me to use? I want this particular image. The local registry will say yes if it did download it before, and things are very quick. Or it might say no, I have to go to the remote registry, dockerhub.com usually, and download it from there. So these are the three components. Let's see how they kind of work down in a brief walkthrough. So when we want to start a container, the host OS will invariably have to pull the image from the registry. Now, maybe it can skip the step, but it can only skip the step if it had pulled the image from the registry, in a past life, right? So you can't have, you can't have something for nothing. But when it pulls the image, it's going to put it onto its local registry. Afterwards, the host OS is going to configure namespaces, right? So namespace, plural, namespaces to create the container, right? And so here are some examples. You might want a network namespace with a virtual Ethernet adapter. We might want a mount namespace for OS files. And you can see how these namespaces, again, combine to form an operating system virtualization. And lastly, the host can launch the container. So the host is going to enter the container's like storage or mount namespace. It's going to try to find a program or a script or something in that storage namespace, and it's going to launch it. And then when that program launches, it can only see what the container's namespace is like have, right? So usually one Ethernet adapter, usually a specific set of OS files, right? Which is very important, both from a security isolation point of view, but also because, if I want a SQL container, that container storage namespace should have SQL, the code, the program installed. And lastly, I haven't talked much about C groups, but C groups is also there just making sure that, our container is not using too many resources. Okay, so this is break time. So think about what I have said. I will be sharing the slides to this presentation right now. So you can look through it over your break if you're interested. But otherwise, we can take a 5-minute break. During your break, if you haven't already, please try to install these tools. So you want to install Docker. That's like the most important bit, obviously. And then you also want to install a tool called Vagrant, um, which is a thing that's helpful. We're going to primarily focus on Docker, do some Vagrant. So if you have trouble with Vagrant, that's okay. Yeah, I'll post the links here. Say, please have installed after a break. And then we will return at 10:40. I'll say 10:40. Okay. I still don't want that. Oh my god. Edit. Okay. This is really embarrassing. Return at 10. Awesome. Okay. Yeah. So if you have any questions, please drop them in the chat. You can look over the slides up here. And then otherwise, try to have Docker installed. And if you can, have Vagrant installed too. Awesome. I'll just quickly share this here. Okay. Thank you. Awesome. So it is 10:40. Hopefully everyone was able to get everything installed if they needed to. Otherwise, I will. Um, you can drop your message in the chat, and I can try to help. Otherwise, I'm going to reshare my screen, and yeah, we can get started. Cool. So let's move on. Part 3, the final part. How do people work with containers? This is probably why you all are here. So without further ado, let's get started. The one thing I wanted to first emphasize is in industry, the practice of using Docker directly is on the decline. You might have heard of this thing called Kubernetes. That's what's really becoming popular. Kubernetes kind of sits behind Docker and uses Docker or Docker related stuff to actually run the containers. Uh, but yeah, that's the one thing I just wanted to mention. So let's take a quick detour and just talk about like what should we think about when we're running containers. First, of course, is the basic operations, like how do we start, stop, delete containers. We also want to worry about ports. So containers are often used for like networking services. So like I want to run a website, right? And if you remember your networking, you know that it has to go through a port, right? So for example, if I was to go to google.ca or even .com, right? I go through google.com, but it's port 443, right? And it ends up at the same place. Um, we want to worry about configuration. So when a container starts, kind of the tricky bit about it is that it's just pulled the image and it's just starting, but we might want to set some configuration stuff, right? Like whether we want TLS enabled, right? The time zone, maybe, or whether to run in the debug or a production mode, right? Or performance and analyzing mode, right? What we'll see is that this is often done through a thing called environmental variables, which is a general concept outside of containers, but that's something to worry about. Cool. Next, we also want to worry about sensitive information. I specifically differentiate sensitive and non-sensitive information because different tools will handle them differently, and because there is sometimes you don't want to just put all of your configuration as like sensitive information, right? Like sometimes you do want non-sensitive information which anyone can read, and sensitive information which is like only maybe the application itself can read. Lastly is you're going to be worried about data storage. So containers pull stuff from images and run. When you stop and delete a container, there goes all of your files. So we might want to think about how do we persist files between like restarts, right? When we upgrade a container, we're actually pulling a new image and starting that container instead. So there's a lot of problems there. I'm just going to breeze through some Linux fundamentals. This is just some boilerplate that we need to know when we use containers. One is a TTY. This is just an abstract like text-based console, right? So if you programmed and you're worried about like stdin and stdout, that's going through this abstract console, right? So if I create a new window, this you can think of so you can sort of think of as a TTY, right? I can type commands in like echo test, right? And this is my input and this is my output, right? You can think that this kind of concept kind of apply to other things besides terminals, right? So if you have like a Linux installation that just doesn't have a GUI, your monitor becomes the TTY, right? It's just a big terminal, right? Or a file, right? Like if you think about logging or that kind of stuff, right? We can just redirect std out to a file and it's fine. The container entry point gets its own kind of text-based console, and this is what it's going to provide a lot of its logging, right? So I start up a web server, and maybe the web server can't receives connections, right? And it prints it out on the screen. That's going to be printed out on a text-based console. The next thing is how do we get help about commands? Of course, you can just Google things now. Google's a very great resource. But oftentimes, if you have a command and you provide dash dash help or dash h or something along those lines, you'll get some sort of help, right? So if I ran docker run dash dash help, it'll give me some stuff. And similarly, if I type in man and then the command, it'll give me the manual for it. So for example, if I did man docker, you can see I'm getting a lot of help documents about Docker, right? Very verbose and like boring, but like very complete too. So let's talk about Docker, right? The most kind of the most salient example. How do we use Docker? So for basic operation, we have a thing called Docker run image, and then we give it a URL of an image. If we provide -it, it'll allocate like a separate terminal and like give you the terminal to use. And then we can use Docker PS to list containers. So I'm going to really breeze through this because it's a very like, again, you can learn Docker on your own, but I wouldn't spend too much time on it because there are things that are kind of replacing Docker today. So I have an image here. It's just a basic hello world stuff. I'll run it in the command lines shortly, but I'll just post it here in case you're interested in checking it out. You can just Google that and it should pop up. The next thing is to talk about ports. So we can the dash that kind of refers to like configuration options for Docker. If we give it -p and give it a host port and a container port, basically it maps the host ports and any connections to the host port gets proxy to the container. So remember that the container gets its own virtual Ethernet adapter. So we have to, so we need to like pass through the connections directly. Let's get started because I do see we are running short on time. So if I do Docker run -p, and then maybe I say 8080, and then 80, and then the image URL or the image like identifier. It can be a URL, but here I'm just doing this kind of as a short form. And I'll copy this into the chat. I run this. What will happen is Docker's going to wait and do stuff. And what I want to point out is what I'm saying is run this image onto a container, and port 80 of the container is going to become port 8080 of of my local host or of the host computer. And I do not know why it is taking so long. I think maybe it is working. So let's see. I go to localhost 8080. There we go. And you can see here there's some 2 HTTP gets. So you notice here I'm connecting to port 8080 because that is on my host port. But what Docker will do is take that connection and give it to port 80 of the container. Right? And if I refresh, you can see it gets another thing. So very, very simple. This image is interesting because it's going to give its container ID. We'll talk about that later. Yeah. The next command is Docker PS. So if I did I ran Docker PS just to check whether the container is running, and it is. And what I can do is delete the container. So I can be like Docker. Well, first I'll stop it to work, but it's going to stop the container. What I copied and pasted, it's kind of hard to see here, is its container ID. So I did Docker PS. It gives me this table-like information, and I copied this and said, okay, Docker stop that, and then it stopped. And now if I try to do this, refresh to port 8080, it's going to refuse to connect because there's no container there to do anything. I'm going to not talk about or not demonstrate the configuration stuff again, because Docker is kind of like a low-level tool now. But what we can do is take directories on our host environment and mount them into the container. And so this is what we call like a volume, and it allows us to pass files back and forth. So just like we can map a host container, so when it connects to port 8080, it connects to port 80. Volumes take a directory on my host machine and gives it to the container, basically. Um, and another thing is environmental variables. So we can pass in environmental variables to Docker. If you're not sure what environmental variables are, do look them up, and then you will kind of see what the value is there. Because then what your program can do is read those environmental values for configuration. Sensitive configuration, it's the same as non-sensitive configuration. So this is kind of a problem we see with Docker, because we don't really want to store sensitive information in a file. We would want to encrypt it if we do, but Docker can't just magically decrypt sensitive information. So this is kind of a point of concern. And for data storage, it's kind of similar to configuration. We can mount a volume onto the container. Containers can also like use other forms of storage. So like a SQL database, right, is a form of persistent storage, or an S3 bucket. So don't think that, oh, when I need to store data, I have to use a volume. Think about what your application is doing, and see, if you're developing the applications, you can, of course, change it. I'm going to just check if there's any questions. Okay. I'm going to just talk briefly about Compose. You might have heard of Docker Compose. Docker Compose uses a config file to define and like spawn containers. So it mimics Docker commands, but instead of writing down like Docker run and Docker this and whatever, you basically say through a YAML file, you say, here's everything I want for Docker to run, and just run it. So do look at Docker Compose on your own time. Moving on, I'll talk about Vagrant. So Vagrant is actually a virtual machine tool. So it's used to create and destroy virtual machines, but it works with Docker as well. So I'm going to drop the GitHub, or a GitHub I made. If you want to follow along, this is what I'm going to be using. And it has a quick Vagrant example. So let's see that in action, because I think that will be the most informative. So hopefully you're able to see my VS Code. If you're not able to. So here in VS Code, I'll make it bigger. We have a folder called Vagrant Example, and I'll just go to that right now. And in this, I have one Vagrant file, and it just has, it's in Ruby, which I don't even know, but it's pretty simple to see what it's doing. So we can see that we want to use Docker, and we want to set the image to be that same image that we used before, and that we want to set the ports. So port 8080 becomes port 80. So what we do is in this Vagrant example folder, we just run Vagrant up. And actually, I made a mistake, because I should use provider equals Docker. And it's giving me a headache, because apparently my port 8080 is already used, which is okay. I'm just going to change it to 1234. So run Vagrant up -- provider Docker, and this should work. There we go. So now it's on port 1234, and that again is being mapped to port 80 on the container side. So I go back here. Oh, let's see it from here. Sounds good. Yeah, I wonder, there has been a problem of, I'll stop my share and reshare again. But I do apologize for that. Hopefully it'll appear on the recording. Basically what I have done is find the Docker image, and then specify the image, and then specify the ports. And I use Vagrant. And even though Vagrant was built for virtual machines, it works fine with Docker containers. And if I go to localhost 1234, it is not working. Let's try first. And let's see if we can. And 7. For some reason, I had to go to 127.0.0.1. Not entirely sure, that might be a bug on Vagrant side. But you can see the same idea. But the benefit, and this is something that Docker Compose will let you do as well, the benefit is you can write this stuff on a file, you don't have to memorize commands, and then everyone can just hit Vagrant up and it'll work. Oh, there was a typo in localhost. Well, darn. Let me try that. Localhost 164. Right. Brilliant. Good catch. So you can see with this Vagrant stuff, a lot of the configuration, we can specify it in a Vagrant file, which is this file over here. Vagrant lets you do a lot of other things, like further like modify your machine, your container after it starts up. So it's a lot of nice options. So yeah, I just wanted to briefly show that as an option. And basically what I want to emphasize is there's multiple ways to use containers, right? It's not just Docker. Cool. Moving on, we'll talk about Kubernetes. So this is just something I'm going to demonstrate here. Kubernetes, to be clear, it's the new like industry dominant tool to manage containers, especially for organizations. The struggle is organizations are having a bit of trouble adopting Kubernetes because Kubernetes is its own thing. But my prediction would be that Kubernetes will eventually replace, uh, everything that organizations are currently doing with like using Docker manually, for example. And the main thing to note with Kubernetes is it's very configuration based. So we do get a tool called kube control, which we can use like a CLI. So it's kind of like Docker run, but really Docker will tell you just use a config file, because that will define these things called components in Kubernetes. And it still handles the rest, supports configuration. It even has its own secrets, like concept to manage secret information. It even lets you use volumes. But one thing to note about Kubernetes is it highly prefers you to use something like a database, because uh, it really doesn't want you to like store data like on a file. Instead, it would rather you use a database. So let's just look at Kubernetes, like give a quick example. So this is in the Kubernetes example. So I have a deployment YAML. So one thing to note is that this is just a text document that describes what I want. And a lot of it is kind of confusing. But one thing to note is the first thing is Kubernetes has this idea of replicas. So this basically means that Kubernetes likes to run more than one copy of your container at once. And so this is useful because if one container fails, there's going to be two others that work through or can provide a backup. Otherwise, a lot of the same information is still there, right? We have a container port, we have an image, we give it a name, that kind of stuff. So let's go to the Kubernetes example. I wrote some scripts just so that I don't make any mistakes in making this. So the deploy is, I'm going to use a thing called micro-K8s, but you can see it's that kube control tool, and I'm just going to apply the deployment YAML. So if I run that, deploy.sh, it just runs this command and it creates this deployment. And then if I did kube control, that micro-K8s is just for like a specific version of Kubernetes I'm using, but really just focus on the kube control stuff. If I did kube control get deployment, we can see that we have these three replicas, right? So there's 3 containers running, and they're all working. So that's great. The next thing I want to do, and this is kind of interesting about Kubernetes, is that it splits up the container from like exposing the container or like the port forwarding part, right? So here I need to expose this deployment. So what you can see is this kube control, expose deployments. I give it the name of the deployment, which is specified here. I will use this thing called node port, but this is basically the replica feature of the port forwarding we saw here. And this name is just giving a name to the service. So Kubernetes has these different ideas of different objects, but the most important thing to note here is that I'm able to use the CLI to expose like port 80 of this deployment. So let's go ahead and do that. So I'll run the expose script. Right? And then here I just do get service. So what this command up here is going to do is it's going to create a service called hello world, right? Which is the same name as here, but because it's a service and not a deployment, it's going to be treated differently. And then here we're just going to list the services active. And if you notice on my terminal screen, again, from my terminal screen, you can see that I have this service called Hello World. It's a node port, blah, blah, blah. And then you can see that it's port 80 has become port 30529. So the first thing to note is that Kubernetes flips this port idea around. So Kubernetes, so Vagrant will say port 1234, which is host side, goes to port 80 of the container. Kubernetes, for whatever reason, does it the flip side. So it's port 80 of the container becomes port 30529 of my computer, right? So my node port. So let's take a look and see if it works. So localhost. So you can see it's working. So basically what is happening is my request from my browser is going to Kubernetes, is going to this idea of a service, and that service is going to connect it to the actual deployment. Now remember that this deployment, if you look up here, has 3 replicas. But what happens if I refresh? The name of the like identifier changes, and that identifier refers to the different replicas that are running. So if I were to spam this a bunch and record the names, I'll notice that there'll be 3 identifiers, and each identifier is from a different replica of this deployment, right? And so this is why Kubernetes splits up the service side from the deployment side, right? Because your deployment has more than one container, and your service will figure out which container to use. And it can do a lot of cool, fancy logic based off of that, but that's outside of the scope of today. Just to end off, so I will take about 5 more minutes. Containers also appear in many other places, right? And so this is part of the reason why you shouldn't emphasize your learning on Docker itself, but more on just containers in general, because we saw Kubernetes kind of takes this idea of containers and kind of flips a lot of things around for very good reasons. If you take the time to dive into that huge mess, but containers also appear other places. So if you know about CA and CD and build tools, you will actually see containers run there as well. So like GitHub Actions or Bitbucket pipelines, especially the pipelines bit. Basically, what these are containers that run when you push code in, typically to the repository. So what will happen is I'll push some code to the repository. Bitbucket will say, oh, I've gotten a push. I'm going to spawn this container, and this container is going to know what to do to like compile the program, to run tests on it, to report any test failures. It goes all the way up to deployment. So it can even like build and release the software, right? So imagine Google Chrome, for example. Some employee at Google types some code in, blah, 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 there's a review process, so on. But then Google servers will use containers to build Google Chrome and to host Google Chrome on, chrome.com or whatever. And that is all automated. And the reason why they're able to automate it so easily is because they use containers. So each container like has all the software it needs to build and to test the software. Containers also appear in developer environments. So if you were here for the dev container workshop, that was just Docker containers, right? And you can see why it would be a very good fit there, because You make an image with all of the software and whatever you need. VS Code takes that, builds it. It can add in its own stuff that it needs to, and then you pass that around to each developer. One person said that the great thing about virtualization is to be able to send it to other people. Really great use here with dev containers. So I can make my own dev container, pass it around to all of my teammates, right? And they're able to recreate the same development environment with the same, software, with even the same VS Code extensions and that kind of stuff. Another example is Git pods, if you're interested in Googling. This is actually a very interesting space because it's kind of exploding with new options. So a really cool place to look at as well. Conclusion. So in summary, containers let us virtualize operating systems, right? And it's usually Linux. And we talked about why we care about this, right? Virtualization has a lot of benefits, and containers are generally preferable to virtual machines because they're a little bit faster and maybe a little bit easier to use, in today's context. And lastly, we explored ways that people use containers. As I said, like we skimmed over some options like Docker Compose, using Docker directly, like Docker Run. That is kind of declining. So always be on the lookout. I showed examples of Vagrant and Kubernetes. I know Kubernetes is going to stick around for a while, but Vagrant might get replaced by a different tool, and so forth. So after this, like, what do we do? Um, you, so here I like to provide some next steps about say you're interested in containers, what should you learn? One big area is Linux administration. I can't recommend this enough for people because it's, as we see, Linux containers are Linux operating systems. So the more you know about how to work with Linux, a lot of that applies to containers. I do explore the tables inside the slide deck. I skimmed through a lot of them, but they do have good information there. And I try to provide stuff to act as a launch board for further Googling. You can explore Docker. We really briefly touched the Docker CLI, so there's a lot more to learn about it. But as I said before, don't spend too much time on it, right? Unless it's for an exam or something, because you can always look up the commands, right? And if you just know the general idea of what containers are, you can just Google, what the exact Docker command is, right? And maybe on your co-op or whatever, you might not be using Docker. You might be using Kubernetes, right? So do keep that in mind. Explore ways to build container images. So we talked about downloading container images, but of course you can build your own. And that wasn't covered in this workshop. It's very easy to do. It does require Linux admin experience and knowledge, but it is fun, but it was kind of outside the scope of today. And lastly, learn other ways to use containers. So check out GitHub Actions, right? You can explore more with Vagrant. If you're particularly keen, you can even try Kubernetes. And if you're interested, I can provide a bit more information about Kubernetes later. And I am trying to host a workshop on it. But yeah, that is the next steps. Thank you so much for coming to today's workshop. I know it's a bit of an odd hour and odd timing with being right after midterms. But with that, I'd like to thank you all for coming and open up the floor for questions. Okay, and I will stop sharing my screen. Otherwise, if you want to leave, that is okay as well. I won't hold it against you. I actually have to go fairly soon as well. But I will wait maybe a couple of minutes in case there's any questions. Feel free to leave whenever. I just don't want to close it prematurely in case someone is typing and I just close the call. Thank you very much, Tulio. I do apologize for some of the timing. We are 10 minutes over. So thank you. Bye. Bye, everyone. Thank you, Oscar. Okay, I am going to stop recording. Hopefully I'm saying your name right. But Kaval, if you have any questions, do feel free to reach out on Discord. Feel like maybe you're just hanging in here, which is okay. So I'm going to go ahead, stop recording.